Hello, everybody. Today we're going to talk about how do you build your own autonomous SRE. Autonomous SRE has been kind of a buzzword for a couple of months or even year. So I'm going to start and talk about that specific use case and what is it even all about and why we're even talking about it. I think there are three main reasons. First of all, one of the things that I think all of you are experiencing is that the number of incidents that we have to deal as a team is growing. The adoption of Kubernetes is growing. AI has contributed a lot because we now have much more content and code that is being pushed into production. And as a result, statistically speaking, we're getting more and more incidents that we have to deal with. At the same time, the SRE number of people, the team itself, is not growing at the pace in which the code is growing, which means that they have much more work to deal with, and therefore the frustration and the burnout is higher. But the MTTR, the mean time to resolution to solve problems, is also growing, and that costs the business with outcomes that are leading towards downtime of systems, failure, dissatisfaction, etc. So AI is also a problem, but also a solution. So what we're going to see is how we can apply, guess what? Agents. So agents is going to be the assistant of that SRE. So you're basically going to watch the system and analyze the logs and analyze other metrics in the system itself and try to diagnose the actual problem in the same way that an SRE human would do. Obviously, it will take less amount of time, and we expect AI to really make that process much easier and reduce the burden for that SRE. In this specific demo, I'm going to help you build something of your own. So I'm going to pitch a product here. I picked a project. It's one of the projects. There are many open source projects now coming to that space, which is called K8sGPT. It's a CNCF project. We're going to start with standing up the demo itself. You see some of the environment already in the screen. I'll walk you through that. Then I'm going to start and trigger some faults. In this case, the famous out-of-memory kill. We'll see how the system behaves. We'll see how to diagnose it and how it can self-heal such an issue. But we'll also talk about the limitations, and that will be kind of a good segue towards the next session that I'm going to do in the next episode. So with no further delay, let's talk about the actual demo itself and the architecture that we're going to use. So as I mentioned, the core of that is based on a project, open source project called K8sGPT. I'm going to explain what that project looks like in just a few seconds. We're going to use Prometheus. So most of it is all open source here. So we're going to use Prometheus as our monitoring system. We're going to use Kind as the Kubernetes cluster. And then we're going to use a sample application, which has a payment API written in Go, recommendation service written in Python. So we're going to kind of try to see how each one of them behave, and a control application that we're using to control the fault ingestion into the actual system itself. Now, the nice thing is that once we detect a problem, we connect to an LLM. In this case, I chose Gemini, but you could choose almost any LLM that you want. That's kind of how that framework works. And it will be used for enrichment, meaning that once we detect a problem, the actual description of the problem is not self-explanatory, and we're going to use the Gemini, in this case, to help us make that much more self-explanatory. Then I'm going to send it into a Slack. So I actually prepared here a Slack kind of terminal that you could see here. We have a channel that is called Incident Demo. I'll share with you all the details how to create all that things later. I think it was kind of beyond the scope of the demo itself. And I'm going to use a terminal here to kick off the actual demo and start the demo itself. I'll walk you through that in just a bit. Before that, I wanted to walk through to what is K8sGPT, who is standing behind it. It's an open source project aimed towards building an open source AI SRE for Kubernetes. It's a CNCF project led by Alex Jones. Alex is now working at AWS and is leading the project. We'll see in a second how the architecture itself is built. So basically, we have the actual custom resource for K8sGPT. Custom resource is an extension of an official extension, standard extension to Kubernetes that allows us to add the K8sGPT. In this case, we have an operator. The operator is the actual controller. What it does is it has a sense of a set of analyzers. The analyzer themselves scans the Kubernetes control plane. So that means pod, services, deployment, PVC, ingress, HPA, all the resources that Kubernetes really manages, and it looks for error at that layer. So note that it's not looking at the application layer, it's looking at the Kubernetes control plane layer, and we'll see what the impact of that layer. Then we have an AI client. An AI client is basically our gateway to the, in this case, Gemini. So it's just a way for us to send messages in a more nicer way using LLM. And a sync is the actual channel. So it could be Slack, it could be Teams, it could be other things in which those messages get forwarded to us. In this case, we chose Slack. That was the most easiest one to work with. And that's kind of the idea behind K8sGPT. And the reason why I chose it, I think it's a very good and easy start to everyone who wants to play with it. It's a single kind of a Helm chart. It's very easy to install, very easy to experience with. And I think it's a very good starting point for anyone trying to understand how to build his own AI SRE kind of project. The project itself, we're going to start with an analyzer that is going to scan. So we install, obviously, K8sGPT in our kind cluster. We're going to inject faults. In this case, we have two faults in this specific demo. One of them is the out-of-memory kill, and the other one is slow memory leak. And then, obviously, that will trigger the actual CRDs. The CRDs are the results. Let's see a little bit more detailed view of that in the Git repo of the demo itself. So we could see them running on my laptop, a kind cluster, which I'm using. Again, everything is running on my desktop. We have one namespace for the demo application, running 3 containers. This is going to simulate the payment service is going to simulate the out-of-memory victim. This is where we're going to inject it. It's written in Go, and it has a smaller limit than the other demo that is written in Python. This is where we inject the slow memory leak into this Python application. The catalog service is just a controller. It's an Nginx application working on that. Now, the way it works is the K8sGPT runs we install it as an operator. It's running on a separate namespace. And the operator itself scans the actual cluster every 60 seconds. It looks for pod deployments and services, and it will supposedly detect the out-of-memory loop and report about it in our Slack channel at the end of the day after going through Gemini. And we also have monitoring in a stack. So this is kind of a pack that we've installed also in the same kind cluster. It's called Kube Prometheus stack, which includes Prometheus, Grafana, Alert Manager, and Kube State Metrics and Node Experience. Yeah, I think that's pretty much it. I think that's kind of what we're gonna slowly go through. The first thing again would be to trigger the out-of-memory kill. It will trigger the out-of-memory kill into the payment service, and then what we'll see is how K8sGPT detect it. So basically, K8sGPT watch for that kubelet mate event. So it looks for events, detect it, and then the whole flow starts and grow. Now to visualize the demo, I installed also a custom Grafana dashboard. You could see it's actually I'm using a port forwarding pointing to a demo cluster overview. This is the custom dashboard that I created just to make things much easier to follow. What you'll see here is that I added a small description here of the actual application, what are the microservices, how they're being set up, how to trigger each of the faults. So it's kind of a guide, a small description of the guide, but also reference to the full description here. Now, the main part is really this one. We're going to see the health of the cluster itself. So we're going to see how many pods are ready. The green obviously means that they're healthy. How many restarts are being invoked in this cluster itself, and an overall health score. If you want to see what each of those metrics really means, you click here, you override, you hover the mark here, and it basically says that health is an aggregation derived from golden signals. So it basically looks at the number of crashes that gives this a 50% score. It looks at memory, and it gives it another 20%. And all in all, it will combine. It's kind of a compound metrics that gives us a compound counter that measure both the memory and the crash loop counter and the error rate, give each one of them a weight, and that becomes the actual health. This is a very common practice, and it's a very good practice when you want to measure health that is not driven by a specific metric. Now, golden metrics is what we use here to have a generic view of the system, a very quick glance view. The term has been coined by Google SRE back in 2014, 2015, as the providing a generic way for us to see the health of the system, not knowing the actual root cause of the problem, but knowing whether the system is healthy or not in a kind of a glance view. It includes something that is called LTES, latency, throughput, error, and saturations. That's the term LTES, what it means. And we can see here throughput. Each color represents one of the microservices. Latency, similar thing. So we see the payment and accommodation. The number of errors. Right now, there's 0 errors. Everything is healthy. Saturation, that's the CPU memory. So again, it looks pretty small. Yeah, utilization, meaning the system itself is healthy. Later, we're going to see the memory utilization. We're going to inject the slow memory, and we're going to see how that affect the recommendation service. And that's pretty much it. Down below, we can see the actual detection, which alerts have been detected, which faults has been detected here. This is actually looking at the CRDs that are being written into the database, the Kubernetes etcd. Here we're going to see the actual calls to Gemini. So I added that as a monitoring just to see how the LLM behaves in the system itself. And here we can see the actual health of K8sGPT itself, the services that are running within K8sGPT, and if they're okay or not. Sometimes I did face issues there. So without further ado, I'm going to start, look here. We're going to start creating a first flow, which is out-of-memory loop. So let's see how that works. Bear with me for a second. So I have a script for each of those faults. Okay, so we triggered the out-of-memory kill. We can see it here. And soon, watch here now, watch the Grafana, and watch the metrics here. Let's see how that affects the cluster. You're going to start and see, it takes a bit of time because we're sampling the actual things. You see it every 5 seconds, it's sample it. We're starting to see the pod starting to restart, and here we can start and see that the health score is getting degraded. What else can we see? So again, it will bounce a bit, but it will get to error state and stabilize at the error state. The other thing that we can watch and see, again, the blue color is the payment services that's been affected. What we can see here is that the actual throughput has stopped, obviously because the pod is continuously restarting. Similarly with latency, so we see here a gap. So the orange line continues, but the blue line is kind of breaking and sometimes have a peak. That's every restart that we're seeing right now. And the number of errors of that payment service is growing quite a bit right now. So as I mentioned earlier, those are metrics that are not specific to this payment and service, that they're not really talking at the language of the application itself, but it's a good indicator to see that something here is broken. So just by looking at that, I can understand that there is an anomaly. There is something that I need to better look into and understand. Here I can see the restart rates growing and all those things which are kind of expected. Now let's watch the Slack. So Slack is, as I mentioned, this is where the SRE is actually getting notified. So notice that this is a message that has been enriched by Gemini, in this case by the LLM. So it's pretty self-explanatory. K8sGPT analysis, pod demo, blah, 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 reports. Error container payment API, which is the container that we injected the error, terminated because it runs out of memory. Solution, one, analyze the payment memory, usage, increase resource limit in its Kubernetes, apply the updates to the manifest. So it gives us also a remediation action that we should and could actually analyze. Now I'm going to reset that failure. So again, watch here. I'm going to run a script to reset that failure. And we're going to move to the next failure, which is the slow memory. And this is where we're going to see a limitation of this framework. As I mentioned, the K8sGPT monitors the Kubernetes cluster itself. It monitors the events of Kubernetes. It monitors the different resources within the Kubernetes control plane, but it doesn't really monitor the application behavior itself. In this case, also, it doesn't monitor the actual metric itself. It doesn't monitor those LTest metrics that I'm mentioning here. So it's kind of blind to those type of errors. Later in the next episode, I'll show you how I mitigate that and how I can extend that framework to address that gap. But for now, this is a known gap within that framework that you should be aware of. Okay, so now we should be able to see that things are going back to normal. Let's see. So we stopped the out of memory. Soon we're going to be able to see that the pod is starting, the crash loop is stopping, and things will start to go back to normal. But we'll give it a few minutes. Here we're going to start and see, you see here, and the green light is starting to come back. We're going to see here that the throughput is starting to climb back to its normal state. Similarly with latency, error will go down. So everything behaving as we expect. So far, so good. Great. Okay, what's next? So the next thing is to introduce the slow memory. Let it stabilize a bit, and then I'm going to kick that off. And this time, we're going to watch this guy here. You see the orange thing here, and see what happens. Okay, by the way, we're seeing that K8sGPT is kind of working pretty hard right now on that kind cluster. The kind cluster doesn't have a lot of resources, I didn't allocate, so that's why you get the latency here. But overall, it's pretty stable. Okay, let's see. Yeah, I think we're good. I think we're good. We can now move to the next thing. Okay, so watch here again. Sorry about that. So we injected now the out of memory leak. So you see script triggers slow leak. And now we're going to see the actual climb in the Grafana of the memory itself. So let's see. Give it a few seconds. Now the thing to watch here is that the memory itself will start to grow, but at the same time, the actual health status here will not change because this is not something that K8sGPT can actually detect well. Okay, let's see, the memory is growing. Soon we'll see it kick off. Those are the type of things that takes a little bit more time to get triggered. Okay, now we're seeing this orange line here. So you see it actually tells you leak enabled. Watch the RSS climb on Grafana and K8sGPT to not detect this. This is what this episode is all about. And let's see here, this orange thing here. So you're starting to see that it's climbing slowly, and the memory is going up, but K8sGPT doesn't really detect it. Okay, so to make things shorter, I'm not going to wait too much about it, but trust me, the memory is going to grow, and K8sGPT is not going to detect it. So I think that's the point is pretty clear. So let's move on. I think that will kind of close the demo for today. We'll now clear again the demo. So I'm going to watch here. And now everything is clear and the demo itself is finished. So let's go back to the description of what we've seen here. So we've triggered an out-of-memory loop. We went through K8sGPT detecting it. It sends the LLM the actual detection. LLM provided the enriched data, which was sent into Slack. We can see here in Slack that this error has been sent a couple of times with a nice description, including how to remediate the action itself. But we also seen that when we triggered an out-of-memory loop, that really wasn't really detected. So as I mentioned, the next episode, I'm going to talk about how do we recover from that. So with that, we'll finish for now. So thank you very much. And if you want to get access to the demo and other things, I'm still preparing this into Git. So subscribe here, and I'll keep you updated with all those artifacts and explanations. And if you have questions, by all means, feel free to reach out and talk to me. Thank you very much.